Okay, so good morning, everyone. Super excited to see all of you here at PromCon today and glad to be chatting about Perses with you. Now, let's be honest, the title of the talk is a little bit of rage bait for those who really love Jsonnet. But does that mean we actually hate Jsonnet? Probably not. I think Jsonnet certainly has its uses as a templating language. It allows for some higher order functional abstractions, which definitely reduces this sprawl of JSON or YAML config that you might have, especially for things like Kubernetes manifests. Jsonnet might actually be a step up from tools like Customize or Helm when it comes to templating. However, maybe JSonnet isn't meant to handle all types of config. So for things like monitoring dashboards and rules, we felt that we could just do a whole lot better, especially in ways that would end up making the dashboard construction process much more end-user friendly and much more durable. So what's a better way? That's what Hélia and I are here to answer. But before that, some short introduction.
Hi, everyone. I'm very happy to be here. This is my first PromCon. So I'm Hélia Barroso. I work as an observability engineer at Five9. I'm also open source contributor, primarily towards Prometheus operator and the Perses project. I'm also a community organizer at my local cloud native community group. And when I'm offline, I like to do what I call granny hobbies, so knitting, stitching, and also reading books and music.
And yeah, this is my first PromCon as well, and my name is Saswata Mukherjee. I'm a senior software engineer at Red Hat, where I mostly work on multi-cluster observability systems. I'm also a maintainer of a few projects you might have heard of, like Thanos and Perses itself, and several other adjacent tools and libraries. You can find me online as at the Saswata code pretty much anywhere, and I occasionally love to do some photography sometimes.
So let's intro into Perses then. And what is Perses? For those who aren't familiar, Perses is an open source visualization tool that allows you to explore and your telemetry data and build dashboards with the main focus of being cloud native and GitOps friendly. This project joined CNCF Sandbox in 2024. And it currently supports all your telemetry signals, so from metrics with Prometheus and Prometheus like long storage backends, but also I already has support for traces, logs, and profiles. But from the beginning, the Perses was first and foremost fully compatible with Prometheus. Not only you can build your dashboards, but also get detailed information about all your metrics and PromQL queries, pretty much the same way you are used to do in the Prometheus UI itself. And for example, one of the latest releases of Perses also brought the quick query viewer that, as you can see, mimics the view that you have in Prometheus for when you're running your queries, so to get information about numbers, series available, labels, and so on. But also, one of the core features of Perses is extensibility, because plugins and data sources or visualization and data sources are developed as plugins. So outside of the core Perses code, it's a lot easier to add new plugins and data sources as needed. It's also embeddable, so you can add a panel from one of the other dashboards or a whole dashboard into your application and keep all the customization in terms of themes that you want to have. As we said before, Perses is GitHub friendly, so you are able to manage your dashboards pretty much as you do any other code through pull requests, and then do all the checks that you need to enforce labels and so on, and also then automate the deployment of your dashboards. And how do you build those dashboards? Currently, Perses supports building the dashboards using Go and Qlang, which is a templating language, which probably are less familiar. And basically, you can build your own dashboards with these two tools. Perses is also Kubernetes native. Thanks to the Perses operator project, you can manage your dashboards, data sources, and deployments as custom resource definitions. And then the operator will continuously monitoring and reconcile those resources. But also, if you're coming from Perses or starting to use Perses, chances are you're coming from a Grafana background, as most of us do, and you're having building so much Grafana dashboards, you might want to keep yourself those dashboards that you already put a lot of work into. And Perses also has a solution to that. You can use the PerseCLI, which is the Perses command line tool interface that you can use to then pick up on your Grafana dashboards and generate the format, the Perses formatting. But also, PerseLI has a bunch of other tools that you can use to manage your dashboard life cycles and also interact with the Perses API. And let's dive now into the Go SDK.
So yeah, we learned about Perses and PerseLI and how we can migrate our existing Grafana dashboards, but we promised a better way. And the first step towards that is the Perses Go SDK. So with every version of Perses, we also release a Go SDK module alongside it, which contains a few builder pattern packages to allow users to essentially construct panels, groups of panels, and full dashboards directly in Go itself. These SDK methods are basically for constructing the same Go configuration structs that exist in Perses codebase. And as Hélia mentioned earlier, Perses is very much driven by its ecosystem of feature-rich plugins. So all of our data sources, as well as types of visualizations, are plugins. And we separately maintain all of these in a repository called Perses plugins and individually release versions of them. Now, of course, talking about Go SDKs like this is a bit confusing. So instead, I kind of wanted to draw out the overall structure of this SDK and how we use it. And it looks something like this. So as you can see from this diagram, to construct any panel of any kind in Perses, you can call panel group.addPanel with several arguments, the major ones being a panel description, then a panel.addQuery method where you can pass in a constructed or slightly templatized PromQL, but more on that later. And finally, you can add another argument for the type of panel you would like. And these come directly from our plugin SDK, which is why I've highlighted them in blue. And these could be anything from like a time series, a gauge, a stat panel, or even a table. And of course, each layer ends up having its own option type that it returns, and the layer above consumes as an argument to make this builder pattern work overall. So as an example of this, you can see this Kubernetes API server availability panel right here. It calls the add panel method with a description, a stat panel chart from our plugin SDK, and finally adds a query with add query. And add query is a builder by itself, which allows you to pass in PromQL as a string, but can also take in options for things like the data source of that particular query, or query resolution or query min step. Now, going a layer over this, we actually have the concept of panel groups. And this construct sort of allows you to group together several related panels.
Yeah.
Okay. With, okay, the monitor no longer works. Should I try plugging it in again? Okay, it's not working. Yeah, it's working. It's back again. At least looks back.
No, the monitors are still loading.
Monitors are still loading. Okay, yes. So to create one, we use the dashboard.addPanel group method, which takes in multiple add panel arguments and also has some customization options for dictating the number of panels that you would like to fit in a line or the height of the panels themselves. And as with everything in the builder pattern library, each layer has its own option. So as an example of this, you can see this read stats panel group, which actually calls our previous panel example along with 3 others. And it also has options for fitting like 4 panels per line and setting the height of each panel to 8. Now with these final groups, we are finally able to construct a full dashboard. The dashboard.new method helps us to do this and it will not only take multiple add panel arguments, but also other dashboard level options like dashboard names and even dashboard variables. So most dashboard functions end up being a bit large, which is why I've split this example. But this is how you would call add variables to actually add a dashboard level variable, in this case, cluster. Here we are using the list variable method from our Prometheus data source plugin to build a list of clusters. And as you can see, it uses the same underlying PromQL query stuff.
You're out again.
Fun. Okay. Anything I can do from my side to keep this from happening? Because I'm not touching my machine. Uh, maybe like there's some sleep mode. I don't know. Okay, we're back again. Okay, and finally okay, yeah, and finally we can call dashboard.new to return the actual Percy's dashboard config. So we saw how we could create dashboards, create durable, accurate version pin dashboards and their panels via easy to use builder methods from our Go SDK, which would throw up errors if you do something wrong. But we are still passing in PromQL as a string and are actually just concatenating strings when we need to templatize those queries with variables. So as you can see over here, we actually templatize via a get kubelet matcher, which calls a global string matcher, right? Now, this isn't really an improvement over Jsonnet as it's just as easy to break and it's not that durable. So what can we do better here?
Yeah, so then PromQL Builder enters the chat. And as the name says, PromQL Builder is basically a way to build PromQL queries in Go. And we have in here as an example a very simple PromQL expression with a metric and labels, but we can go from the simplest to the most complex, and it has a lot of advantages when compared to building dashboard, particularly in the dashboards as code queries as a strings, because the PromQL builder is built using PromQL abstract syntax tree, which by design will going to prevent. You are off again.
Okay.
Okay, we are back again. So let's start from the beginning on this slide. So as I said before, PromQL Builder has a lot of advantages because it's going to be built using PromQL abstract syntax tree. So by design, it helps prevent syntax errors before you even write your query, which is going to impose correct syntax in your expression as you're writing them. So they will be correct before you testing at the runtime. And this is going to make your queries a lot more reusable and resilient because basically you write them once. And if you had proper standards, as the talk before alerted to that, basically means that you can write your PromQL expressions once and then reuse across dashboards, recording rules, alerting rules, and so on. But we didn't reinvent the wheel because the code is already out there. We just put it in a builder, basically. So we use the same Prometheus code so we can take advantage of all the validations that are already in Prometheus to enforce proper standards. And then this will make sure that from the future on, the PromQL builder is always going to be correct with Prometheus standards and query language. So if you go back to the previous schema that Saswata talked about, PromQL builder is now the last piece of the puzzle to have everything built as code. And with that,
So with all these different SDKs out of the way, let's talk about one of the really exciting initiatives we've taken in the Perses community, which is community mixins. By now, you've learned about the various building blocks we have for constructing production-ready dashboards directly in Go. So we have the Go SDK, the plugins, the PromQL builder, and even the schema from Perses and Perses operator itself. So can we build mixins with these building blocks? Yes, we can. But before that, what exactly is a mixin though? So as a monitoring mixer, so monitoring mixin is basically a bundle of dashboard and Prometheus rule configuration that an end user can reuse and choose to extend with their own custom things. Now, traditionally, this used to be fully made in Jsonnet and was imported with the Jsonnet bundler, but that had a few durability issues and also generally low ID support. However, with the building blocks that we have and the dependency management of Go itself, we can basically build mixins directly in Go that Percy's users can simply import and get up and running with. And that's what we did. We created the Percy's community mixins repo as a single place for all Percy's dashboards and Prometheus rules that a cloud native SRE would need to monitor their environments. These mixins are consumable not only as Go methods built from the Percy's SDKs, but we also do commit the generated YAML for it in case you want to directly apply. And we are already a long way in. We have most of the widely adopted mixins already converted, like Kubernetes, etcd, Istio, Thanos, Prometheus, and others. Um, and we also have some convenience functions in Go that bakes in these Percy's dashboard configuration structs into the Percy's operator CRDs, like Perseus dashboards. We also commit these operator YAMLs in case you would like to simply call qapply on them, but you can also import them directly in case you're building some downstream operator that syncs Perseus dashboard CRs. And we have started adding in alerts as well. We've basically relied on the upstream Prometheus operator and Prometheus rule CRD and crafted similar builder methods for the same. So they also use the same Perseus PromQL builder libraries for better durability across versions. And we already have Thanos and Blackbox exporter rules with more coming very soon. The goal of this community mixins effort has been to create effective, durable production monitoring for the Prometheus ecosystem, where we not only rely on the type safety of a language like Go itself, but also actually import the exact configuration structs from our monitoring tools like Perseus and Prometheus in a versioned manner. This creates a durable Go mixin package that can effectively mirror your production monitoring environment on a code level and can even in theory live across your actual workload side by side, evolving with it. So to showcase all of this, we have prepared a demo. Do you want to click through?
Yeah, probably best.
Yeah.
No,
On the thing, exactly.
on that one. So we have recorded a demo. So we have in here a very simple environment that has a Prometheus data source, Perseus. Okay. As always.
Yeah, you just need
I clicked. Okay. Yeah, it's very clear to clicker. So we have Perseus with the Prometheus data source, and we already have in here a dashboard that we built using the Perseus SDK. So very simple dashboard. And you have in here the code, as you can see here, we have a couple of the expressions built using the PromQL builder. And then a bit below, we have a function where we are creating the dashboard for the demo application, where we have the panels that we created with those queries. We have in here just a bit of a rundown of the code to create all those panels. Don't worry, we have the demo repo that then you can access. But because our environment has a Perseus, a Prometheus, and also a Blackbox exporter, we don't want to recreate those dashboards, so we are just going to import them in our main Go functions. And then we are going to use those that are already pre-built. And then a bit below, we are going to generate. Okay, sorry. We're going to generate all the YAMLs to then apply those recurring rules on those dashboards as well. So a bit rundown. So we have in here our own function and also the functions from the mixins repo. And then we just have here the make file to generate those into YAML. And then, like I said, the Perseus CLI to then apply the dashboards to the Perseus instances. And we are going to just, first of all, generate those dashboards and then going to apply those dashboards into our Perseus application. And now, as you go below, a bit below, we already have all the dashboards that we imported alongside the one that we have created. Just a bit of examples because everything was already up and running. And we also have the recording and alerting rules that we imported. And that's it.
Okay, so that's really cool to see, but of course, there's a lot of work left to do. There's a lot that we are working on within Perseus community. We've been really busy at our keyboards, especially for community mixins. We want to make this the de facto standard way of using mixins in the long run. And to that end, we have a lot of things pending. So we have things from finishing the migration to PromQL Builder to adding more alerts to actually working with other upstreams to get their mixins ported to Go as well. And we want to make these mixins way more adoptable. So we've been exploring how to include Perseus operator and the community mixins config directly in stacks like Prometheus, which is super popular. And as I kind of wanted to reference the previous talk because the idea was so cool, but I think it might be even possible to go a few steps further. Arthur and Dominic did an amazing job explaining the concept of trying to generate instrumentation code and dashboards from hotel semantic conventions. I think we could leverage this much further by generating a common Go package with all the constructs we need to both power instrumentation, but also our Go mixin. So instrumentation, alerting rules, and dashboards would all be speaking the same metrics on a code level. And community mixins could even track the upstream semantic conventions. So I'm really excited for the possibilities that such integrations bring to Prometheus and what Perses can do with them. So join us, even if not as a contributor, then at least as a user who would love to make their monitoring more useful and durable. We have our community channels open on Perses Dev on the CNCF Slack. All of our repos have issues and discussions enabled. Thank you.
Thank you. Okay, first question, Matthias.
Yeah, I know.
Hi, since you rage baited me so hard, I have to ask the first question. So one of the things, because why I'm coming back to Jsonnet is always if there's something that I need for my deployment that isn't part of the spec yet in your upstream definitions, right? I can always override that without coming first up to your upstream, making those changes, which was always the problem with Helm charts and Go definitions, etc. So is that something that you're also solving with mixin?
So with these methods that we've built, once you import them, you basically get the structures output. So you can override that as you wish with your own custom values. That's what we have to do because a lot of downstreams have different names, different conventions, different historical contexts that we can't really dictate. So you won't just get the struct as an output. So you can override that.
Okay, that's nice. Follow-up question.
Sure.
Are there any considerations of like integrating all of this more deeply with like generating Kubernetes manifests? Because like one of the things always were like
I
deeply integrated with Kubernetes, right?
In a slide somewhere. But yeah, essentially we have some convenience methods that allow you to basically bake that into the Perses dashboard CRDs. So if you run Perses operator, you can just simply call that method, get the Perses operator CR definition, and apply that. This is actually what we have to do at Red Hat for certain downstream operators where we want to apply it on a user environment, right?
Thank you. Nice work.
Hi, yeah, thank you both for the great talk. Hi, all the way in the back.
Yeah.
I have a question about consuming the dashboards, because I know in one of the more recent Perses releases, we got this download also for the custom resources directly. And then I considered creating dashboards with the Go SDK, and I realized I was too lazy to do that and just downloaded the YAML CRs. Yeah, do you have any plans also maybe with the adaptability for?
Yeah, exactly. So as I kind of mentioned a bit before, so essentially we have the Go methods that would output the Perses dashboard as a struct that you can then call in your downstream Go module. However, we are also committing the entire generated Perses dashboard YAML in the repo in case you want to directly call kubeapply. So both work at the moment. We definitely prefer if you use the Go SDK because that way you have more customizability on your end. Yeah. Does that answer your question? Yeah. Feel free to like catch me later. Yeah.
All right, maybe we have time for one more. While Fiona can already plug herself.
Yeah.
Over there, perfect.
Thank you for the talk. It was really impressive, and I love how structured it is. But at the same time, the code is a bit verbose to define dashboards. Did you see how AI and vibe coding are changing what makes a language, a dashboarding language, good, efficient for a practitioner to define? Is it verbosity? Is it some long?
Yeah, the thing with LLMs, right, is that they have a knowledge cutoff date, which means they don't know anything about what we just built. So you have to teach it a lot of stuff. We definitely try commenting with Godoc, but I've tried and it doesn't generate it accurately enough for my liking, where I end up having to do more work just to ask it to build stuff for me. So it's not there yet, but I think like with more instructions, it could do a good job. There is also, incidentally, I'm looking at Akshay somewhere in this room, but there's also a Perses MCP server, if that's something you're interested in, which can reply with existing dashboards on your end. But yeah, for generating all of this stuff, better to write manually for now, up until it knows about SDK.
Okay. Perfect. Thank you so much again. And